All right, in this lesson, we're going to talk about direct variation, okay? Direct variation is a linear function that can be written as y is equal to k times x, where k is a number that's called the constant of variation, all right? The key here, one of the key things here is that it's a linear function. That means that it's a straight line, all right? And this straight line, one of the things that it always does is that it's going to go through the origin. Okay, so it's going to, if we're talking about on a graph, it's going to go through the origin of the graph. Okay, and if you remember that the origin of a graph is where the two axes cross. That's the point 0, 0. All right, so when we're doing that, okay, first of all, what we need to do is determine whether the data set shows direct variation. Okay, and to do that, we're going to look at whether the difference is linear. Okay, so this would be plus 3, plus 3, and plus 3. So their age goes up by 3. 22 to 24 is plus 2. 24 to 25 is only plus 1. 25 to 26 is plus 2. But this right here shows that it's not linear because the age increases constantly, and a linear equation or a direct variation equation says that the increase in 1, a constant increase is 1, is going to be the same as the results in a constant increase or decrease in the other. All right, so this is not a direct variation. Okay. All right, let's do this. Well, 10, 20, 30, 40. Okay, so that's plus 10, okay? And here we go, plus 25, plus 25, and plus 25. All right, so this is a direct variation. All right, 8, 16, 24, 32, that's plus 8. All right, so, and this is 1, 2, 3, 4. This is plus 1 on all of them. All right, so this is also a direct variation. Okay, 20, 30, 40. This is plus 10 on each one. And 5 to 3 is minus 2, and 3 to 0 is minus 3. So it can go down, but it has to remain constant. This goes down by 2, this goes down by 3. This up here, the distance remains the same. So this is not a direct variation. All right, here it says find the equation of direct variation given that y is 54 when x is 6 and that y varies directly with x, okay? Remember, our direct variation is y is equal to k times x, all right? So all we're going to do here, the big thing that we need to do here is we need to find the constant of variation here. It says that y is 54, so we're going to plug in y is 54 is equal to k times x, which is 6. All right, we don't know what k is. Well, but to figure this out, all we're going to do is divide by 6, divide by 6. 54 divided by 6 is 9, so 9 is equal to k. All right, so now that we have that, the equation of direct variation is y is equal to 9x. All right, this is our answer right here. All right, and we had to do this up here to figure out what k is. And in short, what we did here is that if we said y is equal to kx, in order to find k, it's always going to be y divided by x. All right. So we can, if we need to find out k, this is the way that we do it. K is equal to y divided by x. Okay, find the equation of direct variation given that x is 12 when y is 15. Okay, so remember we just said k is equal to y divided by x, which gives us y is 15, x is 12. When we reduce that down, that gives us 5 over 4. All right, so k is 5/4. It doesn't have to be a whole number. So our equation is y is equal to 5 over 4x. All right? That's all there is to it. And find the equation of direct variation given that x is 28 when y is 14, and that y varies directly with x. Okay? So k is equal to y over x, which gives us y is 14, x is 28. That reduces down to 1/2. All right. So our equation of direct variation is y is equal to 1/2 x. All right. So that does it for this lesson. Make sure that you have copied down the notes, and make sure that if you have any questions at all that you ask me, and we will talk to y'all later on.